Hello. Hello. Hello.
Hello,
Hi,
ma'am.
ma'am.
Hello, beta. So we have everyone
Hello,
except
ma'am.
Iman, right? Okay.
Yes, ma'am.
Um, okay, you can see this assessment schedule that we have, right?
Yes, ma'am.
Yes, ma'am.
Okay, so in
Yes, ma'am.
this case, you can see that we have completed this one, the assignment, it's done. Okay, we've done the quiz. Now we have to do the midterm. So you can prepare for the midterm, right? Now the mode of examination of the midterm, I'm thinking about how we can do it, right? Because we want to be sure that everyone does their own work. Okay. So
Yes,
I'm,
ma'am.
I'm thinking about what mode of examination we can use. It may be similar to what we've done before, or it can be different. Okay. So please prepare accordingly. Okay. So there are many options we can look at. We can look at maybe an option of giving you each a separate question, or we can look at the option of, yeah, I'm looking at something like that. Okay.
Okay,
Okay,
ma'am.
ma'am.
Okay.
Ma'am.
Because I want to be sure that everyone is doing their own work. And I will give you during the class time on Tuesday, 15 December, then you can do this work. Okay. And I will show you, I will of course give you the instructions how you can upload it. Okay.
Okay,
Okay,
ma'am.
ma'am.
मैम
Okay.
ये MCQs नहीं होंगे?
I'm not sure MCQs, but do you think everyone is doing their own work?
Yes,
Who
ma'am.
knows, ma'am?
Yes. Okay. कौन कहेगा yes?
I do my own work.
That's great. I'm so happy to hear that. Okay. Who else does their own work?
Everyone, ma'am.
मैम आप बाद में इसका वाइवा ले सकती हैं to know कि किसी ने
You
अपना
know,
काम
yes, क्योंकि when I see people getting similar marks and similar questions, I become a little bit doubtful, right? So
Yes, ma'am.
I did notice that.
Ma'am,
हाँ जी, बोलो.
yeah, ma'am, it's just like Durdana said, you can take a Viva after the quiz to make
Yeah,
sure if
yeah,
we have cheated
Yes,
or
ma'am.
not.
I can do
Or, ma'am, we can have a video call exam.
a what?
I mean, we can just open our videos and we can do
Yes,
the
I
stuff.
would like you to do that. So I would like you to have your camera. What are you using? What device are you using? I would like you to use your camera video on at the time of the midterm. Okay. So that will be the on Tuesday during the class time. Okay. So you can have
Okay,
Okay,
ma'am.
ma'am.
yes, you can have your
Okay,
cameras
ma'am.
on and you can do it in front of me and you can show me what you're doing. Is that clear?
Yes, yes,
Okay,
ma'am.
ma'am.
And if someone
Yes,
says
ma'am.
that they cannot switch on their camera, then I will not take their exam. Is that clear?
Yes,
Okay,
ma'am.
ma'am.
हाँ,
Ma'am.
I know. Okay, मतलब don't tell me that I don't have internet and I'm having some problem and I cannot switch it on and so on and so forth. right? So please make sure that you have internet. Internet means, you know, you can have a very cheap data package, and that should be enough. You need it for just about 1.5 hours. Okay, so you can have
Yes,
a
ma'am.
data package. You can make a hotspot. There are so many ways of doing it. It's not you don't have a very, you don't have to have a very expensive setup. You can have a very simple small package, but just for a duration of 1 or 2 hours, let's say, a maximum. And during that time, you can switch on your camera, ensure that you have internet so that I can see what you're doing, and then I can ask you questions, and you can show me your work, and you can upload it while I'm talking to you. Okay?
Yes,
Okay, ma'am.
ma'am.
Is that clear? Let's try this method. Okay? Okay?
Okay, ma'am.
Sure, ma'am.
Okay, so now I'm going to go to the whiteboard. Okay? Right. So, let's talk about excitation energy. Okay? So when the incident particle is captured, a certain amount of excitation energy is made available. Okay. So this amount is nearly equal to the sum of the kinetic energy of the captured particle and its binding energy in the compound nucleus. Okay. So
Can you repeat that?
yeah, okay. It should be almost equal to, nearly equal to, okay, the sum of the kinetic energy of the captured particle, which is the incident particle, right? And its binding energy in the compound nucleus. So excitation energy can be represented by E, C, okay? And this is the excitation energy of the compound nucleus, okay? So this is, we are following the assumption that the reaction is taking place through the step of the compound nucleus, as we discussed before. Now, excitation energy EC of a compound nucleus is nearly equal to the kinetic energy of the incident particle. Kinetic energy of the incident particle is EX, right? Plus its binding energy, which according to this book is represented by EB in the compound nucleus in the ground state. So therefore, we can say that EC is approximately equal to EX plus EB, where EB we know, just as we discussed before, that this is equal to the sum of the masses, or the difference in the sum of the masses, right, of the two steps multiplied by, you know, this figure that that has been calculated before, right? So you're familiar with this figure of 931.48 MeV, right?
Mass of proton, ma'am. Mass of
Yeah, multiplied by, and then you convert it to MeV. You know, it's a small problem in which you get this value. It's also explained in the handouts, right?
Yes, ma'am.
Okay. So now we
Yes,
can,
ma'am.
yeah. So we can now look for this expression. And before that, I will also like to explain a term which is called, that we use, but I can explain it, transmutation. Are you familiar with transmutation?
Yes,
a bit,
ma'am.
ma'am.
Yes, what is transmutation?
The change in the nature of a nuclei past the nuclear reaction is called transmutation.
Good, great. Okay, so we can define it as the formation of one element from another. Okay, generally, naturally, as a result of radioactive bombardment, it can take place naturally, or you can induce a nuclear reaction with particles or electromagnetic radiation. Okay, so that was a definition that we will be come across sometimes. And now we can go and try to find the excitation energy. Okay, so I'm going to erase this. So in this case, we can say we have a small particle that we are bombarding. This particle is X and therefore it has a mass mx and it has a, let's say, a velocity v. And we have a target nucleus on which we are bombarding this. The nucleus is at rest and therefore it does not have a velocity, but it has a mass represented by capital M. And the next step is the formation of the compound nucleus, which we are saying is unstable. And we are representing it like this because it's going to break up after some time. And here the mass is M, the compound nucleus, Cn, and it has a certain velocity, capital V. Now let us suppose that the target nucleus is at rest. We've done that. Then according to the law of conservation of momentum, we have mxv plus 0 will be equal to mcnv. And therefore, we can find the velocity of the compound nucleus to be equal to the mass of the incident particle multiplied by its velocity divided by the mass of the compound nucleus. So the fraction of the incident kinetic energy that must be added to the binding energy in order to excite the compound nucleus will be represented by Ex prime. So okay, so Ex prime is defined as the fraction of the incident kinetic energy that must be added to the binding energy in order to excite the compound nucleus. And therefore, we can say that Ex prime is equal to the kinetic energy of the incident particle minus the kinetic energy of the compound nucleus. So therefore, it should be equal to the kinetic energy in written in terms of the masses ratio that we found previously, right? Okay, and we can put the value of V. So instead of V, we have substituted this value. And then we can say so Ex prime will be equal to the kinetic energy and then we can simplify the bracket that we have. So this will be equal to Ex and the ratio of the masses. And then we can have, this is Ex into Mx divided by so we have used the fact that MCN is equal to Mx plus M small x. And therefore, and there we have it. Okay, so from equation 1, we have this is less than Ex. So this will be written in terms of the value that we just found. And this is a ratio of these masses plus the binding energy. Okay, so this is the excitation energy. So these are the different formulas that you will need when you solve the problems that I'll be giving you later. Okay. So I'm going to erase this now.
Okay, ma'am.
Okay. So now we can talk about another concept, which is level width. Okay. So the level width is a certain period of time during which the nucleus remains in an excited state before decaying by the emission of either a particle or a gamma ray. Okay. Okay. So we can say I can write this a certain period of time during which the nucleus remains in an excited state before decaying by the emission of either a particle or a gamma ray. So this is represented by capital gamma, okay? This is equal to h over 2 pi and tau. So this quantity gamma is known as the level width. This is the level width. And it has the units of energy. Okay. And according to the Heisenberg uncertainty principle, we know that this energy multiplied by time, the uncertainty is equal to the Planck's constant, right? So tau is defined as the mean lifetime. This is the mean lifetime. So this tau, which is the mean lifetime, can be identified with time delta t. So therefore, we can say that the level width multiplied by tau should be equal to h over 2 pi, according to this analogy. And when we compare this, we see that delta E is the uncertainty in energy. And therefore, it corresponds to the level width which we just defined, gamma. Hence, delta E is the width gamma in energy of the excited level. Hence, delta E is the width gamma in energy of the excited level. Okay? And so we can say that tau is the level width. Which is the uncertainty in the measurement of energy. Okay. Right. And So reciprocal of the mean life is the disintegration constant. So disintegration constant or decay constant, okay? This is also known as the decay constant. So the decay constant is equal to 1 over tau. What is disintegration?
Breaking of nucleus.
Yes, disintegration is a process in which a nucleus emits one or more particles, right? Such as beta particles, alpha particles, gamma rays, either spontaneously or after following a collision, right? So radioactivity is also a disintegration process, right? So this is the process in which, with the emission of some particles, you know, it can happen naturally or it can happen artificially. So artificially, you have to design a nuclear reaction to do it, and naturally, you know that there are some elements that do emit it. Okay. So this constant lambda is known as the decay constant, or it's known as the disintegration constant. And so we can erase this part here. Okay. So the disintegration constant gives the probability per unit time. The disintegration constant gives the probability per unit time of the emission of a particle or gamma ray Okay, so in nuclear reactions, the energy states excited by nuclear reactions are represented by a quantity gamma, which is proportional to the disintegration reaction. So we conclude that gamma is proportional to lambda, and this means that gamma is proportional to the inverse of tau. Okay. Now I'm going to erase this. Eamon did not join us for the second part of the class.
Yes, ma'am.
है ना?
Yes, ma'am.
तो मैं attendance 2 दफा लेती होती हूँ, you know that. Anyway.
मैम मैं इसको कहती हूँ.
नहीं आप मत कहें, मतलब she knows that we have the class. You don't have to tell her. Okay.
Okay.
So, modes of कौन बोल रहा है? दुर्दाना बोल रही है?
No, ma'am, it's Ramin.
Ramin. नहीं Ramin, it's fine. She knows that we have a class at this time. Okay, so what are the different modes of disintegration? So a compound nucleus can disintegrate in a number of modes, which can be, let's say X plus X can give you y plus q1, right? It can give you y1 plus y2 plus q2. It can give you y2 plus y2. There are different possibilities, right? You can have different types of reactions. Okay, right. So you can have, let's say x plus y or x plus x. This is elastic scattering, right? Where q is equal to 0. And you can also have another kind of reaction, which is x plus x star plus q. So we can have an example in this case. An example can be, let's say, P plus copper 63 will give a compound nucleus, which is zinc in an excited state. And you can have a number of possible reactions. You can have zinc 63 plus the emission of a neutron. You can have copper 62 plus a neutron plus a proton. You can have zinc 62 plus 2 neutrons. So this is an example. So for each possible mode of decay, there is a different probability of decay. For each of these reactions, there's a different probability. And hence a different partial width, a different probability for each of these modes of decay. And hence a different partial width, hence a different partial width, gamma y for each decay product. So the total width gamma of an energy level is then the sum of the individual partial widths. The total level width gamma will be a sum of the individual partial widths depending upon the reaction or the decay that's taking place. So like each of these will have different gammas, and then the total will be equal to the sum of these. And this is a measure of the probability of the reaction. So we can say that this is, for example, if this is alpha, then we can say that this alpha is the probability for the alpha particle level width. Okay. And similarly, if you have for the proton, Tp, so this will be the probability for the proton width. And so on. Okay.
Okay, ma'am.
ठीक है तहरीम? तहरीम है हमारी क्लास में?
जी यस मैम माइक म्यूट नहीं हो रहा था मैम, अनम्यूट।
अच्छा ठीक है, क्योंकि बच्चे बीच में सो भी जाते हैं ना।
नहीं मैम, मैं जाग रही हूँ, मैं सुन रही थी सब कुछ।
ठीक है, चलो सही है। Okay, so we can complete this topic here. ठीक है, so please prepare for your midterm examinations just as we discussed. It's on the, क्या date बताई थी? It's on the
15th of this.
I can leave you with this message. Yeah, share this message.
मैम ये प्लीज शेयरिंग कर देंगी स्क्रीन, अभी लास्ट वो लिख रही थी मैं।
अच्छा आप लिख रहे हो?
जी मैम, सिर्फ थोड़ा सा रह गया।
अच्छा एक मिनट में करती हूँ,
सिर्फ लास्ट वाला रह गया।
किधर गया ये? ठीक है, चलो आप लोग फिर अपना उसकी तैयारी करो 15th December की, and be prepared to have your cameras on, and also your internet should be available. You should be alone sitting in a room. Okay?
Okay ma'am.
पता है ना आपसे?
Okay, ma'am.
हाँ, so let's do it this way. करीम लिख लिया आपने?
मैम बस ये थोड़ा सा रह गया है कि
लिख लें
याद
आप.
कर रहे हैं।
So we will
जी मैम।
complete it here. ठीक है? We are now finished. Okay.
Okay, ma'am. See you,
Take
ma'am, next
care.
Tuesday.
Take care
Okay.
and stay safe.
You too
Ma'am,
मैम।
Thank you. करीम जब आप लिखें मुझे बता देना, मैं एंड कर दूं. ठीक है?
यस मैम लिख लिया। थैंक यू मैम।
Okay. Thank you, beta. Take care.
थैंक यू सो मच मैम। ओके मैम, अल्लाह हाफिज़।
Allah Hafiz.
अल्लाह हाफिज़।
Allah Hafiz.